Sorry, I don't have any notes. Let me just turn off display mirroring. Brilliant. Cheers for the intro, Paul. Sorry it had to be so long. So I'm Patrick, and you can catch me on Twitter at Patrick Hamann. And I'm here, as Paul said, I'm here to talk to you today about how we at The Guardian managed to break news to 1,000 milliseconds, within 1,000 milliseconds, sorry. And hopefully the true meaning of that will be explained throughout this talk. So if you haven't guessed it already, I work at theguardian.com, where I'm a senior developer and technical lead on the core content team. So our web team is split into 3 teams. I manage one of them, and there I specialize in front-end operations and performance. Again, as Paul mentioned, over the last 18 months, we've been building a new, completely responsive website from the ground up. We did not use a single line of code from the old system, completely re-architecting the system for a new Guardian in the future, a Guardian that will be sustainable throughout the future. But as Brad Floss coined the phrase once, of planting the responsive seed. So large organizations like ourselves and BBC News and some of our other friends have, you know, it's a very daunting and scary fact when you turn around to your stakeholders and say, we are going to throw away the whole of the entire previous architecture that you've just invested millions over the last 6 years on, and we want to build a completely new platform. It's you know, they're like, no, you've got to test this first. And so what we did is that we actually implemented the responsive site on our m.dot domain first, on a mobile domain, and then last year when we moved to theguardian.com, we integrated that onto just a single www and using some clever routing at the CDN level. And hopefully, over the next 2 months, it will be coming to a desktop near you soon, and we'll be completely turning off the old architecture. And as well as that, in March of this year, we broke 100 million unique browsers within a single month. And I'm very proud of this stat, and it's a very key cornerstone in the history of The Guardian. And the current platform that we had was just not designed to cater for this sheer amount of users. But also, more interestingly, we are seeing over 6 to 7, these 100 million users are accessing the site from over 6,000 to 7,000 uniquely different devices. Again, the old platform was just not designed to cater for these. We needed a better solution. And so a very good example of this here, we've got the current site on the left-hand side and the new responsive platform on the right-hand side. The new platform managed to render within a second, and we're still waiting slowly as we build the page bit by bit, component with the old site. But what does this actually see? What does this to the user? How does the user really perceive this in real time? Boom, we finished loading the entire site in 3 seconds. We're still waiting. The current median average for load time on our current platform is 10 to 12 seconds. That's not acceptable. You can see there's a recurring theme here. And it's not just the Guardian's problem. So this is a great article taken from the Web Performance Today last year, in March last year. And so this was taken from e-commerce platforms that your average user in 2000 expected your web page to load within 9 seconds. And in 2012, that was reduced to below 2. So again, our current platform isn't designed for this. But still, it's not just the Guardian's problem. In reality, I dig this up from HTTP Archive and pump the data into BigQuery. This is the median speed index for the top 10,000 Alexa websites. Okay? You can see here that the median average is around 9 to 10 seconds. But the 90th percentile is staggeringly between 15 to 20 seconds of the top 10,000 websites in the world. I was shocked when I saw that data. But so it's not just the Guardian problem. You know, we're here in the median baseline. We had to do something about this. But so whenever, I hope when most of you create new products, the first thing you do is go and find out about, you know, maybe our users didn't care about speed. So we went out and we queried 3,000 of our users and asked them about 17 of the key product drivers for the Guardian News site. And they rated, this is very unsurprisingly to me, but surprisingly to a lot of stakeholders in the business, they rated speed as the second most important factor of a key product indicator for our platform only after easy-to-find content. And you'd hope on a news website that the content is easy to find. So our users do actually care. The websites are slowing down, and users are asking for faster websites. And it's not just, you can't just, as well as taking it from the user's mouth, this is an extract taken from Ilya Gregorik's amazing book, High Performance Browser Networking, which I think literally everyone in this room should go out and buy and read. It was the best book of this year. So there's a lot of HCI research that shows that for a user to perceive that a machine is actually working, they have to have a response within 1,000 milliseconds. And after 10 seconds, the task is completely abandoned. And so this doesn't just relate to websites. This could be me at home watching television, changing a channel, clicking a button. I want the machine to respond within 1,000 milliseconds for me to know that machine is working, for me to cognitively feel that this is a fast machine. It is responsive. So let's look at that number again, 1,000 milliseconds. No longer can we as web developers start to think in seconds. We must be thinking in milliseconds. And both Nat and Addy today have shown that clearly. We really need to be thinking in milliseconds. And so what if you could enforce this as a budget as part of your development workflow when we were starting to create the website? Setting ourselves a rendering budget. Our site needs to render within 1,000 milliseconds. Both Tim Kadlik and Brad Frost, again, have been coining this idea of having the concept of a performance budget. And that is exactly what we did at The Guardian. So we call them our lines in the sand, rules that we are not willing to cross. All features must adhere to these budgets, to these lines in the sand. And so we've actually got a lot of them, but I'm only going to focus on 4 of them today. And so for the rest of the talk, I just want to go through our lines in the sand with you and manifest those as such. So the first one, let's dive straight in and take a look. And so one thing that we are very true believers in at The Guardian, we are in the content business. That is our job. We deliver high-quality content to users. Therefore, when we think about responsive design, we actually think of content-first delivery, content-first design. And so that's the only flashy animation I've got in my talk. Let's think of a WordPress site, a normal blog. What happens when on the server side to actually render a page? If a user clicks on a link in Google, goes through to read the article, what's actually happening in the server response there is normally it will be doing a database lookup for the article itself. It will probably then perform another database lookup for the related content widget you've got, another database lookup for your comment section, and maybe the most popular content at the bottom. So all these database queries are building up. On average, your WordPress blog will probably be doing 6 to 8 database lookups before it can even deliver the content to the user. But even though the user only really came to read that article, he didn't care about the side widget or the most popular component or even the comments yet. Each one of those database requests is eating into our 1,000 millisecond barrier. And so on The Guardian, this is our typical architecture of the old site, is that we had to perform 3 database lookups before we could then render it to the user. Each one of these having a tight coupled single point of failure to the services that lie behind them. So, for instance, if the commenting platform was to fall over, so would the rendering of the website. And I'm afraid it did on numerous occasions. Each one of these creating single points of failures to other services, when in fact, the user only really came to read the news. And so we started to think about different ways of creating a service-oriented architecture that we can isolate these single points of failure. The user came to read the news, so we call this process swim laning. We have a line in the sand that says we can only perform 1 blocking database request to our content API, and that has to be the primary content, the thing that the user came there for. The rest of the lookups can be done asynchronously, progressively enhanced. And so if you look at that diagram now, we've created a swim lane, a fault-tolerant system that has no dependencies on its other single points of failures or other services. And so we can asynchronously, progressively enhance the most popular component at the bottom. And then if the comments section was to fail, we still can deliver the news within 1,000 milliseconds to the user, because that's what they came here for. So on the new platform, on the left-hand side, you'll see that's what the initial payload is. A bare bones article, but still the content they came here for. And then eventually, we progressively enhance, asynchronously loading in the rest of the components, each one of them having their own single blocking request rule. If the comments don't load, we fail gracefully. And to me, the biggest thing here is that we've been able to deliver a much faster, resilient to failure of other services, and we can still deliver the news. And for me, progressive enhancement, and this, I went to a great conference on last Friday where my friend Tom from GDS spoke, and this really resonated home to me. Brad Wright at GDS team once said this, that progressive enhancement is about resilience as much as it is about inclusiveness. And to me, that that's how I see progressive enhancement. We want to create resilient systems that are resilient to failure regardless of it. The network, the internet is inherently, sorry, don't know where I was going with that. Let's move on. So for a system to feel responsive, we need to respond within 1,000 milliseconds. We saw that as part of Ilya's slide. But before we do that, I want to take a quick step back and have a look at browser have a quick lesson in browser rendering 101. Nat actually did a very, very amazing job, much better than I could, at doing this. So hopefully we can skim through a bit of it. But the point I want to make here is that having the knowledge of how browsers actually perform rendering, everything from the click on a link on the previous page through the critical path to actually painting to your screen, having the knowledge of how it does that allows us as web developers to make a lot better decisions. We know our application stack very well, but combined with the knowledge of how the browser stack works really allows us to make some powerful decisions about how we load our web pages. So let's have a look at this. It's thinking in mind our 1,000 millisecond budget. Here is a great slide taken from Google's Page Insights resource, showing that actually, on your average 3G connection, 600 milliseconds minimum are already taken up by 3G networking. That's the DNS lookup, and then the three-way TCP handshake, and then eventually making the initial HTTP request, maybe the GET request for your index page, and waiting for the response. So that only leaves us with 400 milliseconds to play with as developers. And I'm telling you, 600 milliseconds is a minimum. On most UK 3G connections, you can't even beat the 1,000 millisecond barrier. Normally, much more. So once we've done that, we've performed the networking, so that's taking up to 600 milliseconds. Once we get the payload back, just the HTML file, we have to start incrementally parsing the DOM. Now, this is one of the great things of the HTML spec, is it actually can be parsed incrementally as packets come in, and we can start to construct a document object model. But if once we're constructing the DOM, if we find a style sheet or a script element, for reasons what we're just about to find out, we have to stop. We have to go back and perform our networking again incurring that 600 millisecond latency, right? Already blasted past our budget. Once we've got the style sheet, we can then start to construct a CSS object model. And so there's a lesser known, just like the DOM, it's still a tree-like structure that contains all of the styles in a node format. But the problem is here is that we have our wonderful friend, JavaScript. So, sorry, I skipped past something there. That CSS can't be parsed incrementally because of the nature of the cascade. You'd paint, and then something later in the cascade would come over, and you'd get this horrible flash and reflows and restyles. So we have to fully download the entire file before we can then parse it. But our friend and foe JavaScript, he is so tightly coupled, interwoven with HTML and CSS that because of the nature of JavaScript could do a document.write, our favorite feature of JavaScript. It might amend the DOM. It might alter it in a way. So JavaScript blocks DOM construction. This is why we have that age-old age or best practice of making JavaScript asynchronous, putting it at the bottom of the page, making a promise to the browser by saying, using an async or defer tag, I know that this JavaScript is not going to alter the DOM. I'm making a promise with you. And so we can take it off the critical path. But JavaScript is tightly coupled with CSS because JavaScript execution cannot proceed until we have a CSS object model because the JavaScript might ask for a style of the DOM. And then eventually, once we have all this information, we create a render tree, which is the mixture of the two of them having all of the information from the top left of the screen, top right, all the way down. And then we can perform the geometry, perform layout, actually work out the size of all these, and eventually paint to the screen. And that's laughing because I've probably got a lot of that information right. No,
just because this is such a horrible, complicated machine.
Yeah, and this is quite a simple explanation of it. It is even a lot more complex, and certain browsers have different nuances. But this is the easiest way of simplifying that. So, but the point I'm trying to make here is how crucial CSS is to your critical path. And so if we look at a traditional web page, we've got our HTML, we then parse it, we find the CSS, we carry on, and then eventually the JavaScript's at the bottom of the page. Now, if we declare to the browser that that's asynchronous JavaScript, you've already knocked off 400 milliseconds off your rendering. And so here, this is the tight coupling between CSS. We cannot render until we've completely downloaded, performed all the networking, and parsed that CSS file. So we must get the CSS down as soon as possible. It is the only thing on your critical path. To me, it is the critical path. And you might see where I'm starting to go with this. So what is your critical CSS? What is the only CSS that you need to be able to paint the core content that your user came here for? But, I mean, with responsive web design, it's pretty tricky. You know, this concept of above the fold no longer exists. So some CSS that might be critical on my mobile device is not critical on my desktop, or the desktop actually might need some more complex styles. It's a very hard problem. But is it your sharing widget? No, and it's not your popular content. You can see where I'm probably going here with. It's nothing of the progressively enhanced component. The only CSS that I really need to render my core content to the user is what they came there for, the article, and maybe a bit of the Chrome at the top, the navigation. So what if we were to inline that CSS into the head of the document, negating the need to perform the CSS, again, the 600 millisecond networking for it? If we had all of the information to render that core content within the initial payload, the first HTTP request, we're creating the most resilient system because we only need one HTTP request to render the thing that the user came here for. The browser wouldn't have to do any more networking. And so that's exactly what we started to do at The Guardian. We started to inline the critical CSS into the head of our document. This goes against everything that we've been taught of separation of concerns, styles in CSS, behavior in JavaScript. It's a very weird concept to get around, but when you see the results that you're going through in a second, it is astonishing. Now, I'm going to mention some tools later that people like Addy are spearheading, is that you can automate the process of this. We choose not to automate the process of it because of what the tricky problem that I mentioned of that what is the above the fold. So we as application developers are the best people to make that decision. So we started off with one head file. We've now got about 4 different head files. We use Sass to do this so that we can maintain the modules, include them back into a single head file, and then get our server-side code to do a bit of I/O, read the file, and just inject it out as a string inside a style element. So let's see how the user perceives this change. So on the bottom is with inline CSS, boom, within 600 milliseconds we've rendered that. We've nearly finished rendering the page, and the first one hasn't even started. Unfortunately, it's with David Cameron's head in it, though. So at the bottom of the page, the observant in the room would have realized that, but hang on a second, you're still going to have to load in the rest of the styles. You can't just have a bare-boned bit of CSS there. So now at the foot of our document, we asynchronously load in the rest of the global styles. So we're doing that here. If we get a 200 response, we do 2 things. First, we inline the CSS. instantly. So we have that again, an instant rendering, although albeit maybe a flash of unstyled content because we've instantly painted with the inline at the top. We then load in the rest. That's obviously going to cause a massive reflow. And so to get around that issue, we actually then store the CSS in local storage. We're using the MD5 hash of the file to do a bit of very simple caching validation. And then, as you'll see it on the next time load, on the second load, we can instantly ask, does the user already have the rest of the global styles in their local storage? If yes, boom. We then have all of the styles, not even just the critical styles, all of the styles of the page within the initial payload. Now, some of the pioneers of this technique, which was actually Bing and Google, Steve Souders wrote an article dating back to 2011 when he started noticing that the search giants were using this technique. They actually use a cookie and to say that the user already has it in its cache. And the only reason why we don't use that technique is that we maintain a very strict no cookie policy. We don't do any dynamic rendering so that we can cache all of our HTML on the edge in the CDN. And so that's why we've opted for local storage, but I'm very open for hearing other people's approaches to this. So let's have a, here we've got our traditional waterfall again. So we're rendering over our budget. We've still got the, the classic three-pronged waterfall. Now, because we've made our CSS loading asynchronous, it's going on in the background, the browser has instant, there's the start render event, shaving off nearly 500 milliseconds of our rendering because we've managed to inline our CSS into the document, breaking the 1,000 millisecond barrier. So now if you were to load our website today, literally, you will notice that in your DevTools, there will be no style sheets loaded. But you will see a string in your local storage. As I mentioned, there's already there's a lot of people pioneering this. The mod page speed module for Nginx does it on the fly for you. Again, one of the main reasons why we didn't use that was because of caching purposes. And Addy's written a very great tool called Critical. I highly advise you to check this out, to automate this as part of your build process inside Grunt and Gulp. And Jonas has also written a different approach to that, using Penthouse, using Phantom to a headless browser to render your page to determine what is the critical CSS. But this is all well and good, but surely this is a hack. We shouldn't be having to do this. And so what does the future hold for us to be able to do this? So the first one is HTTP2. And so it's an IETF working draft that should be finalized by the end of this year. Maybe other people in the room that might be able to tell me differently. But the main thing about HTTP2 is it allows multiple concurrent connections on the same connection. But more importantly, there's a great new feature called server push. So you as a web application developer know more about your application than the browser does. And so what if you knew the next file that the browser is going to instantly ask for is the CSS file? What if when we initially requested the HTML file, we could also push the CSS saying, I know you're going to need this, so have it. And maybe you've even got it in your cache. And so this paradigm of having to load the HTML and then go and load the CSS, and only then do we have enough information to render. In HTTP2 and server push, we can instantly push both files down at the same time. So you've seen that we've designed a system to be resilient to failure. And so we now enforce that every feature has to be resilient to failure that we build. And so I'm sure you've all seen this, probably on a daily basis. And I know I'm a kind of semi-Google sponsored event. I'm not saying that it's Google's fault in any way at all. It's everyone's fault. It just so happened that was a slide. I should have edited that before. But this really is the story of my life. Okay, I do a lot of commuting. I'm on the train. I'm on Twitter. Someone sends a cool link. I click on it, and I've made the networking. I had enough network to get the HTML file, but boom, I go into a tunnel. And my browser has now realized that there's some custom web fonts on that page, and then it has to go and perform them, and it's blocking. It's not going to render. Even though I've got all of the content, I just want to read the article. I don't really care what it looks like that much. And so annoyingly, I don't get to see it. I just get a white page. But the browser is actually probably doing the right thing according to the spec. So the spec is slightly misleading if you ask me, but it says that user agents may render text as if it would be rendered if downloadable. Font resources are not available, or they may render text transparently with a fallback font to avoid a flash of unstyled content. In cases where the font download fails, user agents must display the text. Simply leaving transparent text is considered to be non-conformant. Now, it is our wonderful browser ecosystem, and surely not everyone's going to implement it the same way. So this table was actually taken from a friend of mine who's in the audience. He wrote a very good post titled The Webfontjson and Critical Path by Ian Feather from The Lonely Planet. But you'll see here that every browser is deeming it slightly differently. So IE doesn't block at all, and it doesn't have a timeout. Firefox does block, and it has a 3-second timeout, and Blink and WebKit do block, but don't have a timeout, although they may have changed in recent versions. But why am I talking about this? And this is a very contentious subject that a lot of people say that web fonts aren't crucial to content. You know, I've argued throughout this talk that the user came to see the article, why should they block on a certain resource? The problem for us as The Guardian is that, again, we are in the content business. We are a newspaper, traditionally a newspaper, that our content was printed on paper, and the only thing that makes the Guardian brand stand out against any other newspaper is our typeface. And back in 2006, when we were doing the major Guardian rebrand, we commissioned a font foundry to make a beautiful Guardian Egyptian font. And if you showed someone the website with and without the font, they can instantly recognize that it's the Guardian brand. So to us, when we were developing the project, we were like, we do want that. It is part of our brand. But going back to that idea of progressive enhancement, are fonts really a first-class citizen? We didn't think so. You know, especially when we've got a line in the sand of breaking news within 1,000 milliseconds, surely we won't be able to force the user to block. We want them to fail gracefully. And so Andy Hume, who now works at Twitter and who was our client-side architect at the time, came up with this idea as fonts as a progressive enhancement. What if we could progressively enhance the page and not cause the user to block rendering? So that's what we do. The first thing we do is we ask whether or not the browser is a modern browser. We use the BBC's cutting the mustard test. So if it's not, then show the fallback font. We don't really care. Do they support WAF? Do they support modern font files? If not, they can have the fallback font. Is the font in local storage? If so, great. Let's use it. Let's render. Let's go. If not, do we have enough local storage space? We'll then download a single JSON file, and we'll talk about this in a second. Once we've got that, we'll store it in local storage, and then eventually we can then render again. Never blocking rendering, avoiding that flash of fallback, but more importantly, reducing HTTP requests from maybe 5 or 6 font requests down to a single HTTP request, and caching that aggressively in local storage. And so what we do is we actually base64 encode the font file into a string, with the key being the font name and then the value being it. Now, yes, I know that base64 encoding a font file is actually going to increase it in size, but the trade-off here for us is having that one resilient HTTP request rather than multiple that are going to take longer, and we can actually cache that aggressively inside local storage. And so we open source that as with most of the things we do. So you can check out the npm package Webfontjson or the grunt task grunt web font. But again, there must be a better solution to this. So the first one is the font loading spec. This has actually been implemented in JavaScript. I don't know how far. I know Chrome are definitely working on it. Jake Archibald's got a great post on it. But the most exciting thing to me with this is that it uses the new native DOM promises API, so that you can actually use promises to do things with events. We have a lot more greater power over controlling when and when not do fonts get loaded and what to do in cases of fallback events, all with native promises. So it's amazing. Allow us much finer control. But this is probably one of the most important things I'm going to say tonight, is service worker. To me, this combined with HTTP2 are literally the most important things coming to the web stack over the next 5 years. this is going to literally revolutionize and change the way we develop web applications. And as I mentioned at the beginning, for me, progressive enhancement is resilience, and Service Worker is designed for an offline world, having offline-first web applications. But for me, more importantly, it's about having resilient web applications, ones that don't care about the networking, don't care about the network stack, will always still be able to render, regardless of the location you are or whether or not you have network. And so with Service Worker is a separate process, one that's intercepting every single one of the networking requests on the page, and then you can actually decide whether or not you want to respond from the network or respond from a cache. So we now have new cache objects coming to JavaScript, that much more advanced caches that will be able to store items and retrieve them based on certain keys. And so imagine my CSS in local storage, my fonts in local storage. Now I can actually have a place where I can cache this, but more reliably decide whether or not we actually want to go back onto the network if the user has it, or return from a cache, even whilst offline. And so the final point here I want to make is about, it's all well and good developing in your controlled environment with your 16 gigs of MacBook Pro with that T1 connection that your office got. What are your real users seeing? How are these features performing in production? How do you know if a resource is failing? And so we do that with a lot of strict monitoring. And so the first thing is, as you saw that with the CSS inlining, one thing I mentioned was that we have to restrict that file to 14 KB. If a lot of you know about the networking stat is obviously the first part of the connection window and the first few TCP packets, that we must maintain a small enough file that is not actually going to be detrimental to our payload. And so my developers, I saw them a lot kind of going, yeah, I know that's all well and good, but how are we going to stick inside this budget? So I wrote a grunt task that in our CI server, it monitors the size of all of our static assets and pinging back to an Amazon CloudWatch the raw and gzip file size of that. So then I could use CloudWatch's thresholding and alerting on that I literally get an email when we commit some code that breaks the CSS past its 14K budget. And so, because I found myself quite a lot having to keep a watchful eye on our pull requests in GitHub of saying, is your feature really critical? Does it need to be inlined in the head? Is it above the fold? Or are users really going to interact with that instantly? But now I have a system that tells me when we've broken that budget. And so real user metrics. Having synthetic analysis is good, but knowing when and how something's broken in production or how fast your site is in production in real time has literally been invaluable to us. So we use the navigation timing API to beacon back on, we have an in-house analytics tool called OFAN that was actually a system designed for the editorial team based off one of our hack days, but then turned into a fully fledged product. It allows the journalists to see what content is trending in real time, where referrers are coming from, what was recently published. They use it as their day-to-day editorial journalists. But we were beaconing back information. So as engineers, we were like, hang on a second, we're missing a trick here. We can add some of our own data to that request, and they'll never know. And so we started using the navigation timing API that exposes all of the timing data down to the millisecond of the core loading events for the page. So your DNS lookup all the way through to your final load event. There's a lot of great third-party tools out here. You don't have to just roll your own. And so here you can see our median average is perfectly staying underneath our 1K budget compared to the old website, which got its horrible 12-second median load time and its 4-second DOM content ready. In real time, more importantly, I can know if a deployment that I've just made has affected our performance. And so this is one of our developers two weeks ago changed, we started loading WAF2. So it's actually only supported by Chrome at the moment. But so we could filter to see by device, by its user agent down to Chrome, and instantly see the impact that had on our users. And amazingly, because of the way that WAF2s are constructed, you actually get a lot smaller file sizes. We managed to shave off 400 milliseconds just by doing that change to our fonts, but knowing in real time how we did it. This isn't really about performance, but I sneaked it in here because it's one of my favorite tools at the moment. This is called Sentry. And so we wanted to know how our JavaScript was performing in production and if it was breaking. You know, you can never test on every single permutation of JavaScript engine, device, and operating system, and browser. Even if you've got a fully fleshed device lab, there's no way that you'll be able to test on every one. So what if you were to monkey patch window.onError, catching all of the events and beaconing them back to a server so that you can then aggregate those results? And so this is exactly what Sentry does for us. And so I can now, in real time, get an alert if we introduce a new JavaScript error into production that we might not have caught through unit testing or integration testing, give me a breakdown of the browsers that it's happening on, the build number of our server that's happening on it. But the most amazing thing is literally, it gives me a stack trace. It tells me where in my code base the JavaScript error is being thrown. Through the nature of source maps, we can now even get that back to a single module. Again, your system telling you of its own ill health, automating this. It's amazing. So I mentioned real user monitoring, but obviously there's always a place for synthetic analysis, so you can track your trends and outliers over time. So for this, we use speed curve. Speed curve, the greatest thing about it is being how we expose it to the business, or how by default it exposes itself to the business. So we made sure as the team that actually rather than just it going to myself, it goes to a distribution list with the whole department. So we get a weekly email every Monday morning from SpeedCurve telling us how our site performed performance-wise over the last 2 weeks. But this makes everyone accountable for the change, which is extremely important when you're trying to change performance culture within a business. And so the great thing here is that I might have not noticed that we've actually gone up with our median load time last week, but then my product owner on a Monday morning gets an email saying that, and he can instantly email me saying, hang on a second, Patrick, what did we do last week? This has been invaluable. And lastly, once you're getting and gathering all of this metric data, please make sure to set alerts and thresholds on it. Your thresholds will probably be wrong the first few times with kind of outliers and boy who cries wolf, but you'll be able to tailor them and then know instantly if you've broken your performance budget. So again, last section, what does the future hold for us on this? The first one is the nav timing API is great but that only gives you, but for security reasons, only gives you access to the initial HTML document. But surely you want to measure all of maybe the third parties. You're using the Facebook API. You want to know when that breaks, or even our own services that I'm progressively enhancing in. How do I know if one of those features dies out? So we've got a new resource timing API that applying a header to those resources, it tells the browser, yep, you're safe to give this user in his JavaScript the timing information for these requests. So then, again, you can beacon them back into real user monitoring, set your alerts so you can know even when your external services or internal services go down. And lastly, the beacon API. This is one of my favorite APIs. So, we're gathering all of this data, and unfortunately, the pure nature of analytics is that the old hack has been using an image tag to send these quick, simple, dirty GET requests or POST requests. But the beacon API allows you to make asynchronous requests. So you tell the browser, right, I want you to send off all this metric data back to my service, but I don't care when you perform the networking for it. Or more importantly, let the browser decide when it has networking for it. And that's very crucial on mobile, because the browser knows when the radio is active, but you as a web developer don't. So my final point is that having these lines in the sand has enabled us to create a conversation, both with everyone in the company, be it a designer, a product owner, stakeholder, or third parties even. It allows us to say, no, we can't actually do the design for that feature that way because it will break this line in the sand. It allows you to start having these conversations, creating rules around them. And if you're going to stay for the pub or anything, I'd be really interested to hear if any of you have got the same rules, or tell me about how you're implementing budgets inside your organizations. So finally, here's some takeaways and things that I've learned along the way. Everyone must be involved in baking performance into your workflow from day one. This is not something that you can retrofit. It's not something you can chuck over the wall to your operations team. Don't worry, they'll sort out the performance problems. Performance is a first-class citizen. It must be part of all discussions you have for new features. And everyone should be held accountable for change in performance. I hope this resonated throughout my talk. Just deliver your core content first and then progressively enhance the rest of it. Set a performance budget, but measure, optimize, and repeat constantly, right? You can't, and it's not something you can just do now for a month, right? We'll focus on performance for 2 weeks. It's going to make it fast. Your site will slow down. I promise you that, right? That's the nature of building software. The products do slow down, so you have to constantly be measuring them, optimizing, and repeating. One of my favorite quotes from Paul is, "Don't guess it, test it." Isn't that right, Paul? Yes. Yes. And the final point is, it is a requirement. It's not a feature. Thank you. So you can catch us on, the whole project is online, open on GitHub. So if you want to find out more about the code and how we're doing it, go and check it out there. And you can catch my slides at that URL. Thank you.
So you load the content in last, right? Yeah. Okay. Thank you again so much for coming out. Sorry it's run on a little bit longer tonight, but I hope you've enjoyed yourselves. If you can, do join us at the pub, and if you could just give our speakers, Adi, Nat, and Patrick, one more round of applause, that'd be great. Thank you.